This is the beginning of lecture 23. It's not going to be in two parts. It's just going to be one part, lecture 23. It's a short lecture just to close the loop on quantifying the carbon in the carbon cycle. By now, you should have know firmly that certain gases can absorb infrared energy and trap heat. And you should have reviewed some of your basic chemical fundamentals, your quantitative skills using the Pogel activity and some of the slides from lecture 22. So you should be all up to speed on your math and converting from grams to moles and whatnot. So now we're ready to answer, start to look at this question about how much is too much when it comes to carbon dioxide in the atmosphere. So thinking back about the carbon cycle again and recognizing that this number here, 750 gigatons, is the amount of carbon in the atmosphere, and knowing that the carbon in the atmosphere is largely in the form of carbon dioxide, but it comes from the carbon that was fixed in fossil fuels or in plants, and is then released into the atmosphere. So we've got carbon cycling back and forth from hydrocarbons, solid carbon in the form of coal, and carbon dioxide. So it's a pretty complicated system, but what we want to do is see how humans are disrupting the natural cycle by burning fossil fuels and putting more carbon in the atmosphere than the ecosystem has come adjusted to. So it's burning fossil fuels and deforestation. Those are the two human causes of increasing the carbon in the atmosphere. Okay, so now we're ready to answer the question that we posed at the beginning of the last lecture, which was how much carbon dioxide is released in the atmosphere when 3.3 gigatons of carbon is cycled into the atmosphere. And we know that 3.3 gigatons number comes from the human factors and how much extra carbon is going into the atmosphere that cannot be pulled back down by natural carbon dioxide dissolving in the oceans and being absorbed into living systems through plants. And so anyway, so how much carbon dioxide is released in the atmosphere when 3.3 gigatons of carbon is cycled into the atmosphere? Assume that all the carbon in the atmosphere is in the form of carbon dioxide. Okay, so we're going to answer this question. I'm going to put a fresh piece of paper up here so we have plenty of space. So what you want to do, well, first of all, is look at the question. So the question is, or what we want to always say is, what's given and what's wanted. In this particular question, what's given is 3.3 gigatons of carbon. And what we want to know is how many gigatons of carbon dioxide does that relate to? Okay, assuming that all the carbon in the 3.3 gigatons is found in the form of carbon dioxide. So we're going to have to just do a conversion. Okay, let's see here. We're going to do a conversion. The conversion path is going to be from gigatons of carbon to gigatons of carbon dioxide. And the conversion factor that we're going to use is this concept that in a pure substance, in a compound, the number ratios of the different elements within the compound are fixed and the mass ratios are fixed. Okay, so since we know that 1 mole of carbon weighs about 12 grams and 1 mole of oxygen weighs about 16 grams, that information we can get from the periodic table. We can set ourselves up either a mass percent ratio or just a mass ratio. In the Pogel activity that you just did last time, you were looking at mass percentage. In this, I'm going to just use a mass ratio. Okay, so the conversion factor is coming from the fact that the amount of carbon in carbon dioxide is fixed. Okay, that's our reality. All right, and so that means if carbon from the periodic table is about 12 grams per mole, I'm rounding off here, carbon dioxide is going to be, the mass of carbon dioxide is going to be the mass of the carbon plus 2 oxygens, And rounding off from the periodic table, oxygen is about 16, and we have 2 of them. So that'd be 16 plus 16 plus 12. You can do that in your head. That's about 44 grams per mole. Okay, so then I can make a ratio and say, okay, the ratio of carbon to carbon dioxide, the mass ratio is 12 to 44. 12 grams for every 44 grams, because the 1 moles would each cancel off. Or I could also write my ratio in terms of carbon dioxide per carbon, and that would be 44 grams per 12 grams. That's a mass ratio. It's always true because the amount of carbon in carbon dioxide is fixed. That's the definition of the pure substance, the pure compounds. Okay, and so so from this fact, I get these conversion factors. 12 grams per 44 grams of carbon and carbon dioxide, or 44 grams per 12 grams for carbon. Those are the ratios. So since I need to convert from gigatons of carbon to gigatons of carbon dioxide, I'm going to start with what's given, 3.3 gigatons of carbon, and I'd like to know how much mass of carbon dioxide that is. Then I'm going to have my unit of carbon on the bottom. And since this is a ratio, it doesn't matter what unit I use as long as it's a mass unit. So the ratio is 44 grams to 12 grams. It's also 44 kilograms to 12 kilograms, or 44 gigatons to 12 gigatons. So that's the unit I'm going to use, since that's the unit I'm using here. 12 gigatons, and then this unit would cancel, and then now I have a nice conversion, and it's 12. We do the math. 3.3 times 44 divided by 12 is 12 gigatons of carbon dioxide. So that's how much carbon dioxide we're releasing per year into the atmosphere that needs to be dealt with. That's a lot of carbon dioxide.